Okay, now in 4.4, we learned what this means. We learned that this is like a vertical stretch of compression. This moves it left and right. This moves it up and down. Therefore, if these move it up, down, left, right, I know that this is the vertex, right? So this is why it's called vertex form, this equation. You should know how to graph x squared quick. If you have a regular x squared, it's just at 0, 0, at 1, 1, and at 2, 4. But I want to talk about how to graph it really quick, because if it's not at 0, 0, there should be a way to graph it quickly in terms of like understanding a pattern. And that pattern is called step pattern. So anytime I'm graphing a parabola that has an a value of 1, okay, an a value of 1, all I have to do to find other points is, remember rise over run? It's not rise over run, it's just over 1, up 1. And then it's over 1, up 3. And then it's over 1, up 5. So the step pattern is 1, 3, 5. So anytime I'm graphing a parabola, if I know where the vertex is, I just go over 1, up 1, plot a point. Over 1, up 3, plot a point. Over 1, up 5, plot a point. But really, I wouldn't even use the 5 because like that's always like off my chart because it's so exponential, right? So I really just need 1 and a 3. That's enough points for a parabola most of the time. Now, take a look. If I had to graph this parabola, assuming that there's still a 1 in front of there, I just figure out, okay, well, if it went h to the right, the vertex should be at h, and k up, it just went up to k. Here's my new parabola, but look at the step pattern. Over 1, up 1, there's a point. I'm gonna go this way. Over 1, up 3. So the step pattern is still 1 and 3 every single time. Okay? When the a value is a 1. Okay? There's going to be times where we have to graph a parabola where the a value is not a 1. If this a value is like a computable number, you can still use step pattern. You can technically still use step pattern no matter what the number is. It's just probably not a good idea if it's like a 1 over 144. It's probably going to be a little difficult. So in this question, you should know where the vertex is, and if you know where the vertex is, plot it. Just plot the vertex. It's at 4, negative 3. 4, negative 3, there's my vertex. And if you know where your vertex is, it's really easy to plot the other parabola using the step pattern. I have to go over 1, up 1, over 1, up 3, over 1, up 5. But because there's an a value that is a 2, I just multiply the vertical numbers by 2 because it's a vertical stretch. So I have to go over 1, up 2, and I plot a point. And I'm going to mirror that point on this side. It's symmetrical. I'm going to go over 1, not up 3, up 6, double the 3. So I'm going to go all the way up to 6, and it's off my chart. I'm going to mirror that point over here, and I'm done. So again, I plotted my h and k as my vertex. That's 0 out of 10 difficulty. Just plot the point. Make sure you do opposite of what this number is in here. Positive 4, negative 3. Then I use this to multiply it by the step pattern. So I go over 1, up 1 times 2, because the a value is a 2. Over 1, up 3 times 2, which is a 6. It's off my chart. Kind of just know where it is, and I plot my parabola. Okay. Now it says describe the properties of the parabola with this equation, so I'll just verbalize them. This means a vertical stretch of by a factor of 2. It means all my y values are being multiplied by 2, and we'll get into that not on video. This means I'm moving my parabola over to the right by 4 units. If you want mathematical terminology, horizontal translation. Translation is when I move something. Transformation is when I transform something. So a horizontal translation, 4 units to the right, and a vertical translation, 3 units down. Okay? That's just like the English way to describe those properties. But as long as you can plot that vertex, find some points, done. Worst case scenario, if you find the vertex, you know you probably need some points around the vertex, right? So you can just plug in like some points into the equation. Push equals in your calculator. I don't want you to do that, but you could do that still, right, as a backup. You shouldn't be using a calculator really anywhere. It's so fast to not use a calculator. Harder is going backwards. If you see a parabola, you have to determine what the equation is, and where you're going to make a mistake is always going to be the a value. The a value. If I know the vertex is 1 and 5, very easy to come up with my equation. It's y equals x minus k squared plus 5. Remember, h and k is the vertex. H and k. It's moved over 1 to the right, so -1. It's moved up 5, so +5. But don't forget, you have to have an a value every single time. That's where the mistake's going to happen. If I ask you this on a test and you just give me those two, you get 2 out of 4 marks, because it's another 2 marks to find a. Now, to find a, you need another point that's given to you by the question. It can be given explicitly, or it can be given in a different sense. Maybe like a receiver catches a football this far away from the quarterback at this height. That's a point in space. Oh, the receiver caught it at 2 meters and it was 40 meters from the quarterback. Boom, you know the XY, you know the X coordinate, you know the Y coordinate. So I have to substitute this point into XY there and isolate for A. My Y value is a 2. My X value is a 0. And now I just bedmass to solve. This is a 2 equals A. That's just a 1. I gotta bring that 5 over. This is a -3 is A, and I'm done. I'm not gonna divide by 1. If that was a 2, I would have to divide by 2 at the end. But now that I know A, I can finalize and say Y equals -3 x minus 1 squared plus 5. Done. So to find H and K, I do it visually. Where the vertex is, done, brainless. And then to find A, I gotta pick a point on the parabola that is not the vertex. I'm gonna say that one more time. Pick a point on the parabola that is not the vertex. There's one. If they didn't give me one, either look for one that you know, or you can't do it. Plug it in, solve for A, recreate my equation with an A value now. Notice how there's a negative in front of here, so the parabola opens down. Next, word problems. Obviously, word problems are sometimes a pain. I don't think they're as hard as the chapter 1 word problems, not even close. So at a fireworks display, a firework is launched from a height of 2 meters above the ground. I'm kidding, don't hold fireworks. And reaches a maximum height of 40 meters at a horizontal distance of 10 meters. Find an equation to model the firework. If you can't picture this in your mind, then draw like a really crappy image about what it represents. So this is my crappy image of this firework. It's not going to be to scale. I'm not going to put numbers. Firework is launched from a height of 2 meters. So I'm launching it from 2 meters. That's the 0. So at 0, it's 2 meters. Reaches a maximum of 40. This is not even to scale. I don't care. 10 meters away. So there's my vertex. Take a look. Gets launched from here, hits 40 when it's 10 away. Find an equation to model the firework. Okay, well I have the vertex and I have a point. And I know the parabola is going to kind of look like this, right? Something like that. I don't really care how the parabola looks. I have the vertex and I have a point. So I can come up with the equation. I'm going to say y equals a x minus 10 squared plus 40 because the vertex is 10, 40. You can determine that from the question without drawing a picture. Go nuts. Now I gotta pick a point and solve for A. I'm gonna pick this point. It's the only one that the question gives me, the starting height. Therefore, that's gonna be 0, 2. I'm gonna go here, plug in a 2, plug in a 0, and solve. I'm going to bring the 40 over. It's going to be -38. -10 squared is 100. So this is going to be 100A. So -38 over 100 is A. I can reduce that here to -19 over 50 equals A. Okay, reduce them both by 2. Now I can finalize my equation and say, well, therefore the equation is going to be y equals -19 over 50 x minus 10 squared plus 40. Okay, just because the a value is an obscure number like -19 over 50, doesn't matter. You can still find it by plugging in whatever the question gives you, right? Easy points. Okay, this next question, there's always like follow-up questions. So really focus on coming up with a good equation first because the next questions will be based on this. Now, fireworks don't explode usually at their maximum height, right? They'll like fly in the air, and then as they fall, it's time, so they'll probably around there. Around the vertex, they'll blow up. If the firework continues to travel an additional 1 meter horizontally when it explodes, what is the height when it explodes? So it's saying that it's exploding like 1 meter away from the vertex. We know that that x value must be 11. Yes, sir? No mistake? All right. So it's asking, what is the maximum height at that level? I know it's going to be less than 40 because it's reached its maximum height already. But to determine at what height that is, I just have to take that 11 and plug it into my equation that I hope is true. So I'm going to go like this. Y equals negative 19 over 50. 11 minus 10 squared plus 40. Y equals, that's a 1 squared, so that's gone. So it's really just 40 minus 19 over 50. Negative 19 over 50 equals plus 40 equals 39.6 meters. 0.62 meters. Therefore, blah, 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 blah. The height of that firework when it explodes is actually 39.62 meters. If you got 41, you're obviously wrong, because it can't explode higher than its highest point, which is the vertex. Okay, so when you get a word problem, a very quick little crappy diagram just always helps, okay, for sure. You want to come up with your equation, you need the vertex for this section. Vertex is guaranteed. Use your vertex, plug it into your vertex form, and then use another point that the question gives you somewhere to substitute for x and y, and then you have to solve for a. Once you solve for a, reduce it if you have to. Don't turn it to a decimal. Just leave it like this. There's your equation. Follow-up questions are always going to be, use your equation to do something. Really easy. And that's it for this section, but we'll talk more about it.